This is section 5.2, and we're going to talk about inverse functions. So some actions are reversible. Think about it. If you put on a coat and go outside, what would be the inverse of that? So if you're going to reverse those actions, what would you do first as a reverse? You would go inside and then take off your coat. It wouldn't make sense to do it the other way. So whatever the last action was, you typically do that as an inverse first. Now mathematically, let's talk about the inverse operation. So if you're multiplying, then the division is the inverse. If you're adding, the subtraction will be that. So let's look here. If you had subtract 7 from x and divide the result by 2, you could write that as x minus 7 over 2. Now the last thing we did was divide by 2. So for an inverse, we're multiplying that x by 2, and instead of subtracting 7, we're going to add 7. So we could look at that in the calculator. We could put y1 as this original, y2 as this, and then I put in a y3 and said that's x, because those two, the yellow and the blue, are inverses. And if they're true inverses, they are symmetrical about this line, y equals x. So if you're looking at a picture or a graph, you should be able to tell whether something is an inverse. Now let's talk about one-to-one functions. Remember when we learned the definition of a function and it said x could only be paired with exactly one y. Well, if it's a function and y can only be paired with exactly one x, so it's the inverse of that, then it's a one-to-one function. And we had a vertical test, a vertical line test to see if something was a function. Well, we have a horizontal line test to tell if it's a one-to-one function. So if we draw a horizontal line through and we hit it more than once, it is not a one-to-one function. This one is not. So we'll do a few of those in your homework. Now, inverse notation is f and then a -1 up there, but that isn't f to the -1, it's f inverse. Now, we're going to talk about algebraically how to find the inverse. And here's some steps to break it down. Number 1, replace f of x with y. 2, interchange x and y, because that's what happens in an inverse. 3, solve for y, and then put your y back into this notation. So let's look at an example following those steps. Find the inverse of f of x equals x cubed minus 2. First thing I did was write it as y equals x cubed minus 2. Then I exchanged. I put y here, I put x cubed over here. And I'm going to try to solve for y. So first thing is add the 2 to the other side. If I'm solving for y, I need to get the cube root of this. You have to cube root both sides. So y is the cube root of x plus 2. Then I changed y to f inverse, and that is my inverse function. So, and think about it. Here we're cubing x. Here we've got the cube root of x. We're subtracting 2, we're adding 2. So hopefully that should make sense. And just real quick, the domain of f equals the range of f inverse. And the range of f equals the domain of f inverse. They just switch. They switch places. So that's shown right here with the numbers. If you have x and f of x, and you've got x and f inverse, the numbers just switched. So that's why they are symmetrical about that line. All right, let's go look at our problems. All right, so first we're just looking at the verbiage. State the inverse action of the action below, climbing up a ladder. Well, the inverse would be climbing down the ladder. Number 2, inverse of walking in a classroom, opening a book, and sitting down. Remember, we start at the end and inverse that way. So standing up, closing the book, and walking out of the classroom, that would be the inverse. Describe verbally the inverse of this statement. Add 6 to x, so that's x plus 6. Inverse of that would be to subtract 6 from x. So here's x plus 6, here's x minus 6. That's the inverse. Now we're asked to do the same thing here. Add 2 to x and multiply the result by 2. So what's the symbolic expression for the given one? That would be 4 parentheses x plus 2. What is the inverse? Well, we're going to divide by x by 4, and we're going to subtract 2. We chose that one there. So divide by 4 and subtract 2. 5, 6, and 7, we're deciding about 1 to 1. Consider this graph. Is it 1 to 1? I just drew a line right there to just remind you that yes, that is. This one, no. This one, no. I think that looks just like number 6. It says, is that a 1 to 1? No. All right. Is this 1 to 1? Yes, this would be. Now, using a table to determine if f is 1 to 1, you want to look to see if y is repeated. In this one, y is repeated. You got 2, 6. If y is repeated, it is not 1 to 1. Is this one 1 to 1? Y is not repeated. So yes, it's 1 to 1, and it'll have an inverse. Is this 1 to 1? No, because we could draw a line straight through here and we'd hit it twice. Number 12, we're going to find the inverse. So we start out with y equals cube root of 6x. We change x and y. Then we've got to solve for y. So we're going to cube both sides. We'll divide by 6. And they've already got the f inverse notation here, so we're just putting x cubed over 6 in there. Number 13, the function is 1 to 1. Find its inverse. Y equals 7x minus 1. Switch x and y. Add 1 to this side. Divide by 7. So y is x plus 1 over 7. 14, find a formula for the inverse. 3x cubed minus 4. So y equals 3x minus 4, x cubed minus 4. Switch x and y. We're going to solve for y. So we're going to add 4. We're going to divide by 3. Then we're going to take the cube root of both sides. So it's the cube root of x plus 4 over 3. Number 15, we got negative 5 over x. So we got y equals negative 5 over x. Now, we have to switch x and y. And in order to solve for y, we need to multiply y over here so that we don't have a fraction. We've got xy equals negative 5. We're solving for y, divide by x. I wanted you to see one because sometimes a graph can be an inverse of itself. So that's what we end up with here. Number 16, and I think it's our last one. It's a little bit more involved. We're going to find the inverse of this. So we've got y equals 1/6, parentheses 18 minus 5x, plus 1. The first thing you should do is go ahead and multiply 1/6, distribute it here. So you have 3 minus 5/6 y plus 1. Go ahead and combine the 3 and the 1. So now you've got 4 minus that. Subtract the 4. So now you have x minus 4 equals this. To solve for y, we have to multiply by the reciprocal of this. So we'll multiply by negative 6 over 5. Those two cancel out, and we've got that over here. The way they'd like you to write the answer is to put it all over 5 and put negative 6 on the top, x minus 4. And that would be your inverse for that one. So most of those go pretty quick, and I think that should get you going on inverses.